64% સોલાર કન્વર્શન ઇફિશિયન્સી, સોલાર પાવર પડે આપણા સોલાર સેલ ઉપર, એને 64% રૂપાંતર ઉર્જામાં રૂપાંતર થાય. એટલી બધી કેપેસિટી લોકો બનાવી દીધું છે. 64%. આપણે જો સોલાર સેલ વાપરીએ 10%, 12%ના સોલાર સેલ વાપરીએ, but people have reported up to 64% of the solar conversion efficiency. So you can think about some new materials. So I am not talking about semiconductor solar cells. Now I am talking about organic solar cells. These are called as dye-sensitized solar cells. સોલાર સેલ માં જે ઉત્પત્તિ થાય ફોટોવોલ્ટાઇકની, હવે જો ડાય-સેન્સિટાઇઝ સોલાર સેલ છે, these are organic solar cells. These are organic solar cells. અને આપણે નેશનલ કેમિકલ લેબોરેટરી પૂનામાં છે, NCL માં બહુ મોટું કામ ચાલે છે અત્યારે. NCL માં they are working in a very big way to develop the dye-sensitized solar cells or organic solar cells. અને એમાં જો એનર્જી ઉત્પન્ન થાય છે, ઉર્જા ઉત્પન્ન થાય છે, જેવી રીતે પ્લાન્ટ્સમાં ફોટોસિન્થેસિસ, ખબર છે ને તમને? ફોટોસિન્થેસિસ આપણા પાંદડામાં ઉર્જા ઉત્પન્ન થાય છે, જો આપણા ઝાડમાં જાય, જો જે પ્રક્રિયા પાંદડામાં થાય છે કે આપણે સૂર્યનો પ્રકાશ પાંદડા ઉપર પડે અને એમાંથી આપણે એનર્જી મળે જાણવા માટે, સેમ પ્રક્રિયા તમે સોલાર સેલમાં કરો. સેમ પ્રક્રિયાથી તમે ઉર્જા ઉત્પન્ન કરો, જેવી રીતે ફોટોસિન્થેસિસ થાય છે આપણે એનર્જી થાય, સેમ ટાઈપ ઓફ પેરેલલ પ્રોસેસ ઇઝ બીંગ ડન in the dye-sensitized solar cell. It's a very, very virgin area of research and development, that is energy conversion. So these are important. Then oxide materials, they are very, very important because oxides can be functionalized as per requirement. So I am talking about new class of oxides called as functional oxides. આખું પેપર રાખેલું છે MSc માં 4 વર્ષથી. Functional oxide, they are not normal oxides. These oxides are developed or studied to perform certain specific functions. So I coin a new word for you. This is a very common word in our field, but for you it is called as engineering of materials. So materials engineering is a very important branch of the science, applied sciences. I am not talking about pure engineering, but materials engineering. તમે engineer કરો material, નવા materials બનાવો, શોધ કરો મટીરિયલ્સમાં અને એને વાપરવા માટેની એની પ્રક્રિયા બતાવો. So therefore this is called engineering of materials. So therefore what are the materials? High TC superconductors, in which I did my PhD long back, that was 87 to 90. I was in TIFR Bombay. So therefore this is HTSC. These are not normal superconductors. Normal superconductors નથી. I am not talking about normal metallic superconductors. These are oxide superconductors. 1986 discovery by Bedloes and Muller, March 1986 discovery. So then Nobel Prize. Then magnetic materials. These are oxide materials having magnetic properties. Oxides ખાલી insulators નથી, એમાં magnetic property બહુ જ interesting છે. આયર્ન, કોબાલ્ટ, નિકેલ કરતા પણ વધારે સારી interesting property oxidesમાં magnetism છે. આપણે શું લાગે magnetism એટલે દર વખતે આપણા મગજમાં આવે છે Fe, આયર્ન, કોબાલ્ટ, નિકેલ. 3D elements છે ને બધા, 3D1 to 3D9. Yeah, 3D10 is completely filled, so magnetism is not there. But 3D9, correct, your 3D10 is fully filled. Magnetism માટે unfilled જો છે ને, લાસ્ટ unfilled હોવી જોઈએ. So 3D1 to 3D9. Magnetism is interesting. Iron, cobalt, nickel, vanadium, chromium, titanium, whatever it is. But more interesting is magnetism in the oxide materials. Very interesting. A material which is ferromagnet at certain temperature, it becomes paramagnet. A material which is ferromagnet becomes antiferromagnet. It becomes ferrimagnet. So you have got very interesting phase transitions in these oxide materials. Therefore oxide magnetism is very, very interesting. Oxides are very friendly to work with rather than metals. Metal તકલીફ છે બનાવવા માટે. Alloys બનાવો તો તમારા માટે arc furnace and induction furnace બહુ costly છે. And then you need to have very specific vacuum and all those things, airborne atmosphere. Metal ને alloy બનાવો ને, સંયુજ બનાવવાનો બહુ તકલીફ થાય છે. પણ ઓક્સાઇડ બનાવવામાં કાંઈ નહીં, એ ખાલી તમે ઓલો પેસ્ટલ મોટર લઈ લો, આપણે દાદી મામા કરતી હતી ને, આમ મિક્સ કરતી ચર્નિંગ, એવી રીતે લઈ લો, એ 2000 રૂપિયામાં મળે આગળનો, એમાં તમે ઓક્સાઇડના કામ ચાલુ કરી શકો. I will tell you some marvelous oxides also in future. So now coming to the strong linkage now, as I told you in this slide, a strong linkage is there. Nanomaterials are very important material for the strong linkage. See, it's a linkage between composites. It is a linkage between energy materials, oxide materials, and so on. All types of materials, they are linked through the word nano. Nano means in Gujarati we call nano, very small, 10 raised to minus 9 size. 1 nanometer to 100 nanometer. कोई पण एक डायमेंशन होय, कोई पण एक डायमेंशन जो 1 to 100 in range में होय, then we call that material as a nano material. So this is a very big, good linkage between them. Then coming to the oxide materials, as I told you the word functional oxides. Functional oxides માં ઘણા બધા આવે છે. I have listed only 4 out of them, in which we are working extensively from the last 20 years. I have been working. I have published large amount of papers in this. High temperature superconductors, materials of 1980s, 1980 ના materials છે બધા, 85 ના. પછી CMR materials, early 1990s, 91-92 માં આવી ગયા છે materials. Then diluted magnetic semiconductors. These are not normal semiconductors. Remember, ફરીથી તમને કહું છું, normal semiconductors are germanium silicon based semiconductor. Otherwise, I am not talking about normal semiconductors. These are magnetic semiconductors. Semiconductor ની property પણ છે અને magnetism પણ છે. બે property એક જ material ધરાવે છે. Diluted, very small percentage doping. Then multiferrites. These are the new materials of the future. Not normal ferroelectric materials. Barium titanate, strontium titanate. આ ferroelectric materials. ખબર છે તમને? Ferroelectric અને ferromagnetic બે પેરેલલ ચાલે છે. Ferromagnetic materialમાં magnetization હોય, spontaneous magnetization. Ferroelectric materialમાં polarization. Electrical properties identified by polarization. Magnetic properties identified by magnetization. બે પેરેલલ ચાલે છે મતલબ. So barium titanate, strontium titanate, BaTiO3, SrTiO3, these are ferroelectric materials. So I am not talking about those materials, I am talking about multiferroids, which have got 2 or more than 2 orders of ferrite orders are there. These are multiferrite materials. Then coming to the metals, I will not go into the details of metals because these are very conventional materials. After gear assemblies, everywhere metals, but now these gear assemblies, earlier conventional metals are being replaced by polymer gears now. અત્યારે બધા composites and polymers ના gears આવે છે. જેટલી નવી બડી મોટી કાર આવે છે અત્યારે, metal gears are being replaced by the polymer gears and composite. Lightweight, durability is large, wear and tear is very less as compared to metals. Metals માં ઘસારો વધારે હોય છે, એટલે gear assembly તમારે દર 5 વર્ષે 10 વર્ષે બદલવું પડે. પણ એમાં પોલિમર્સમાં ઘસારો બહુ ઓછો હોય છે. So therefore I will not go into the details of metals. Then coming to the ceramics, where I am working for many years. See, ceramics, they are very hard, they are brittle, refractory grade materials. Ceramics are prepared at very high temperatures. 1000 degree, 1200 degree, 1400 degree માં ફાયરિંગ કરવાની. તમારે રિફ્રેક્ટરી બ્રિક્સ ખબર છે તમને? આપણે થાનગઢથી રોડમાં જાઓ તો તમે રેલવે ટ્રેકની બાજુમાં ઓલું નહીં ઈટ પડેલી હોય, રિફ્રેક્ટરી મટીરિયલ બધું તૈયાર કરી નાખેલું હોય ને, ભટ્ટીમાં ચડાવેલું, એ રિફ્રેક્ટરી મટીરિયલ્સ. સો therefore these are ceramic materials are refractory, wear resistant. So therefore wear losses are very less in the ceramics. Then non-magnetic. So normal ceramics are non-magnetic, but you can make them magnetic also. You can make them magnetic by special process. You can make a magnetic ceramics also. Then chemically very stable. Ceramics are chemically very stable material. They are thermal insulators. So they are thermal insulators, so they are used for many applications. Then they are oxidation resistant materials. Ceramics, they do not go under the oxidation process. Otherwise metals માં oxidation થાય. Metal તમે ખુલ્લું રાખો ને તો ઓક્સિડાઇઝ થાય અને પછી કાટ લાગી જાય. તમે લોખંડ હોય ગમે તે કાટ લાગે. સિરામિક્સમાં એવું કંઈ પ્રોબ્લેમ નથી ઓક્સિડેશન્સનો. Then electrical insulators, thermal insulators, electrical insulators. એટલે અત્યારે આપણે જીબીની જેટલી લાઈનો હોય ને, મોટી લાઈન, તમે જોયું ને ઓલું રાખેલું હોય લાલ, ઓલો આમ હોય ને, એમાં તાર વીટેલી હોય છે. What are these? These are ceramic materials. They are electrical insulators, very high electrical currents, but they are insulators in nature. Then they are prone to the thermal shocks. So thermal shocks હોય તો ceramicsમાં તકલીફ થવાની શક્યતા છે. So these are the properties of the ceramics. Then coming to the polymer materials, I will not go into the details about the properties, but actually these polymers are very important because their properties are large. Their variation in the property is very large in case of polymers. So therefore thermal expansion coefficient is very much different. These are crystallization temperature, latent heat of crystallization, thermal conductivity. So I have listed few of the properties. Mechanical properties of polymers are very interesting. So therefore, I told you that in the automobile industries now polymers are used. Polymers are used for the handles also. Composites are used for the steerings now. Composites and polymers are used for the steerings. The polymers are used at many places for packing materials also. So gas permeability property, water absorption property, water content, tensile modulus, elastic modulus. So all these are properties of the polymers. Then coming to the second set of properties of polymers. So they have got a tensile strength, compression strength, impact strength, dielectric permittivity, electrical property, friction resistance. So you can see a material possessing almost 80 to 90 properties. Variety of properties is there. And that's what I told that in this coming era, polymers are going to play a very important role. Polymer ni chemistry hoy છે. Like there are two aspects of studying polymers. Polymer physics, applications of polymers, and chemistry, how to make long chain polymers, how to make short chain polymers. These are the combination of the organic molecules. So therefore, depending upon that, so polymer chemistry is very, very important. Our university department is known for that. Like Sardar Patel University at Vallabh their chemistry department is also well known for the polymer research. Our department is also well known for the polymer research. So polymers are used in day-to-day applications at variety of places. So these are the different properties of the polymers. They are used for the environmental stress proper behavior also. Then coming to the composites now. As I told you, the composites, they have got a reinforcement pattern. So they have got a one over the other. Composites materials may be a layered materials also. So therefore, they have got heat treat temperatures are quite high. They have got fiber volume fraction very large. Bulk densities are very, very low. Porosity is a very important property. Actually, porosity, if you have got a very highly porous material, then the density will be? Yes, very good, very good. So therefore, there is a relationship between the porosity and the density. So if you want to make use of any material which is very lightweight material, but along with that, it should have a very large mechanical strength also. તમે એક સાઈડમાં પ્લસમાં જાઓ તો બીજામાં માઇનસમાં જાઓ એવું નહીં ચાલે. So therefore you have to develop a material, whatever you feel that material should have a property, you should be able to develop that material. And that